start. So let me just say this one more time. So the major topics in this class: limits. Then we talked about derivatives based on limits, of course, because we know the derivative is a limit of the difference quotient, right? So the limit needed, we talked about the difference quotient, then limits. The difference quotient is an algebra topic. And then limits in calculus, and then derivatives, and then all sorts of applications. So now we reached the third level of integration. I will explain what this means, but first I need to explain other things. Okay, number one. Let's suppose we have the distance function. So I'm going to say the distance s of x. I have this function. When I find the derivative of the distance function, I find velocity. Now we want to go backwards. So when we were given the distance function in the previous chapters, we found the derivative of the distance function because we created a new function. We wanted to look at a new function, which was the velocity function. What do I mean by backwards? Now we have, or we are given, the velocity. I am given, in other words, v of x. That's the velocity, v of x. And I'm asked, find the distance function. So they are giving us basically the derivative of a function, and they are telling us, okay, I'm giving you the derivative of the distance. Find the distance function. Go backwards from the derivative to the function. So far, we went from the function to the derivative. Now, in chapter 4, we will learn how to go back from the velocity, from the derivative back to the function. This process is called anti-differentiation. Going backwards, in other words. Anti-differentiation. Anti-differentiation, meaning going backwards. I'm given the derivative, and I'm asked to find the function. Okay, now, let's suppose I have this function, a very simple function, x squared minus 3x plus 1. It's a quadratic function. I'm going to say this is a derivative. Derivatives are functions as well. So I'm given this derivative, and I am asked to find the most general antiderivative. Of this function f prime. I will explain what I mean by the most general antiderivative. Let's talk about the rule, and then I'll explain this. Promise. Okay. So I see that this function has 3 terms. So I have to come up with 3 terms. So in such a way that when I differentiate this piece, the first piece, I get x squared. When I differentiate the second piece, I get negative 3x. When I differentiate the third piece, I get 1. But also, the most general antiderivative, I have to have a c here. C stands for any constant. And you'll see in a minute why. Now, how do I determine the function that I would differentiate to get x squared? Here's the rule. x to n plus first over n plus first, where n is the power. N is 2 in my case. So then I will have to write x to the third divided by 3. N plus 1 over that number, n plus 1. Does it work? Let's convince ourselves. When I differentiate x to the third divided by 3, I bring 3 down, I simplify, I subtract 1 from the power, and I get x squared. Now I will copy negative 3, and I will use the same rule to find the function whose derivative is x, meaning power 1. So 1 plus 1 over 1 plus 1. So this means x squared over 2. Does it work? I don't know. Let's check. Bring down 2, simplify, and I get back negative 3x. So final question I have is this. Which function prime is 1? Can anyone tell us which function prime that when we differentiate it, we get 1? Is there a function that we differentiate to get 1?
So just x.
Just plain x. Thank you. And of course, all this is called the most general antiderivative, or it's a family of functions whose derivative f prime of x is x squared minus 3x plus 1. Infinitely many functions. Infinitely many. Why? Because c can be 0, c can be 1, c can be negative 3, c can be 10,000, c can be 1,000,000, c can be negative 1,000,000. It doesn't matter. When I differentiate everything, I always get that function. Let's do it again. When I differentiate this, I get x squared. When I differentiate this, I get negative 3x. When I differentiate this, I get 1. When I differentiate this, I get 0. Therefore, this is a family of functions, or the most general antiderivative. All these functions, no matter what c you pick, it doesn't matter. All these functions have this derivative. Guaranteed. Okay. We do have a symbol that we like to use. But before I go back to the symbol, I would like us to choose a function and again reinforce the difference between the derivative and the differential of a function. So can anyone give us any function? Any function you want. And we want to find its derivative, and we want to find its differential. And then I'll explain the symbol that I wanted to continue with. Can anyone give us a function, please? Can anyone give us a function? Any function, please? Can anyone give us a function? No one wants to give us a function? Okay. E to 3x plus 2x squared. Now, can anyone give us f prime? Can anyone?
The
Yes,
3e to 3x plus 4x.
very good. Now we want to find the differential. So this is indeed the function. This is indeed its derivative. But now I would like us to find the differential of f of x. This is a crucial topic here. We've done this many, many times before. I would like to have it here, right here in front of us. Can anyone give us the differential of this function? We have the derivative, but we also want the differential. And they're not the same. And there is only a very, very simple formula. Anyone? Anyone remembers the formula for the differential of the function?
Is that when it's f prime times dx?
Exactly. So it's dy, the notation is dy, and this is f prime of x dx. Very good. So let's write the differential of this function. It's very important to remember the name. Good? So what does it equal to?
It's 3 to the 3x plus 4 times dx.
Very good. Everything in quantity dx. Perfect. Good. That's all I needed. So now you'll see in a moment why. We can determine the most general antiderivative by simply writing f of x, la la la. But there is another way. So we're given the function, I'm repeating the calculation with the new notation that I will show you right now. So x squared minus 3x plus 1. That was the exercise, the problem that we looked at. We are given the derivative, and we're asked to find the most general antiderivative. And here's the notation. So S stands for sum, S-U-M. In this chapter, in calculus in general. So S stands for the sum. But the Latin S is not a good symbol. We're going to stretch it. So instead of writing the regular S, I'm going to stretch it as much as I can. What do I mean by that? Here it is. Instead of writing S, I'm stretching the sum or the letter S as much as I can. And I will have f prime of x dx. So the symbol is called the indefinite integral. What will the answer be? Exactly the same thing. It will give us the most general antiderivative of the function we started with. It's just that we are using a sophisticated, if you want, symbol, which is the indefinite integral of dy, of the differential, which is f prime of x dx. So finding the most general antiderivative can be done by hand if you want, or just with the regular symbols, or it can be expressed as an indefinite integral, of course, of f prime of x dx. That's why I emphasized for almost a month, I would say, the difference between the derivative of a function and the differential of a function. The differential is part of the indefinite integral. That's why I want you to understand this integral does not exist without dx. So we continue. So I have the indefinite integral of, so this is the sum. I'll explain where the sum is coming from. Maybe not tonight, but definitely next week. So for now, just believe me, trust me, that this is basically a sum, but the symbol has to be stretched so we can have enough room to write f prime, which is in parentheses, x squared minus 3x plus 1 dx. From this point on, the procedure is identical. Which function prime is x squared? Is still x cubed over 3 minus 3. Which function prime is x? As we calculated, is x squared over 2 plus which function prime is 1? Of course, we already know it's x plus, and I can never forget, because we are looking for the most general antiderivative. It's a family of functions. Infinitely many functions have the same derivative. Why? Because c can be anything. Okay, I want to open the book on page 392. Really? 392, please. Good. So you see all sorts of examples here. Many. So let's start. Let's choose anything you like. Let's say first from 5 to 20 to find the most general antiderivative using the indefinite integral symbol. So let's choose. If not, I will. Okay, I will start with 11 on 392. So the indefinite integral from 1 over x to the third dx. Of course, I will change the indefinite of this function from 1 over x cubed to 1 over x cubed into x to the negative 3 dx, of course. And I will use the exact same formula. What formula? I will increase the power by 1 and divide by the resulting number. X to negative 3 plus 1 over negative 3 plus 1 plus a constant c. Of course, I will not leave it like this. I will calculate x to negative 2 over negative 2 plus a constant c. I will bring the negative power back to the denominator and put a negative in front. 2x squared plus a constant c. Question. Can I check the result of an indefinite integral? The answer is absolutely yes. How? How do I check? How do I check my work? Very simple.
And you just do the derivative of it.
Exactly. So the answer is yes, because differentiation and now that the next fancy word, differentiation and integration. What is this? Well, it has to do with the symbol. indefinite integral. So that refers to the process of integration. The derivatives refer to process of differentiation. The indefinite integral refers to the process of integration. So these are two major processes, and they're inverses of each other. If I differentiate an integral, nothing happens to the function. If I integrate a derivative, nothing happens to the function. They are inverse operations. So, differentiation and integration are inverse operations. So let's go back for a moment to our first example. We said that the indefinite integral of x squared minus 3x plus 1 dx, we found that the answer was x to the third over 3 minus 3/2 x squared plus x plus c. Is it really true? I don't know. But I don't need anybody to tell me yay or nay. Because what I'm going to do is I'm going to differentiate the left-hand side, and I'm going to differentiate the right-hand side. If I get the same thing, then I'll say that's correct. If I don't get the same thing, then I'll say, oops. So, differentiation and integration are inverse operations, which means applying the differentiating process on an integral makes this symbol and dx go away. So what is the left-hand side? Just x squared minus 3x plus 1. So when I differentiate the indefinite integral, the symbol goes away, dx goes away, and I have back the function. Let's see if I get the same thing on the right-hand side. If I don't, then this is wrong. So I differentiate x cubed over 3, so I get x squared. I differentiate negative 3/2 x squared, bring down 2, simplify, and get negative 3x. I differentiate x, and when I differentiate x, I get plus 1. When I differentiate any constant, I get 0. And look at this. I can always check the result of an indefinite integral. The result of an indefinite integral, which was this, I can always check by differentiating both sides. The left-hand side cancels and I get everything, but everything goes away except the function. And on the right-hand side, I differentiate and I have to get the function. Otherwise, the result was incorrect. So you will have no homework for Monday because I would like you to focus on the test and finish it up. I haven't finished section 4.1 yet. We have a lot more to work on and more examples.